This is section 9.5, factoring x squared plus bx plus c. In other words, we're now going to take a trinomial and make it the product of two binomials. The only way to solve polynomials is to factor and set each factor equal to 0. The most basic trinomial is x squared plus bx plus c. Here you can see there's no coefficient in front of the x squared term. The coefficient's actually 1. We don't show the 1, we just assume that it's there. An example of this would be x squared plus 3x plus 2. In order to factor x squared plus 3x plus 2, we're looking for a couple things. We're looking for two numbers that multiply together to be 2 and add together to be 3x. So in this case, it's pretty simple. It would be 2 and 1. 2 times 1 is 2, and 2 plus 1 is 3. You can see this written out here in a variable form. What we're looking for is to get it into two factors, x plus p and x plus q. P plus q must equal the b term, and p times q must equal the c term. An example here is x squared plus 5x plus 6. In this case, in factored form, it's the quantity x plus 2 times the quantity x plus 3. And the way we reach that is we found that 2 plus 3 equals 5, and 2 times 3 equals 6. When b and c are positive, it is the simplest case. You need two factors to add together to be a positive number, but they have to multiply to also be a positive number. The result of this is logically that both p and q must be positive. If they're multiplying together to be positive and adding together to be positive, they must both be positive. Take a look at this example. X squared plus 11x plus 18. We know right away, since the 11x and the 18 are positive, both terms have pluses inside them. So we're going to have x plus some number and x plus some number. We need two numbers that multiply together to be 18 and add together to be 11. So think of all the factors of 18. 6 and 3, did they add together to be 11? No. 18 and 1, did they add together to be 11? No. 9 and 2, though, do add together to be 11. So if we put 9 and 2 in here, and then we FOIL that, we see that we would come right back to the trinomial that we have above. So it's x plus 9 times x plus 2. That equals x squared plus 11x plus 18. In the second example, x squared plus 3x plus 2. Again, both the 3x and the 2 are positive, so we know in both factors there's going to be a positive. So we can start out just writing the parentheses and the x terms with the plus signs. Then you can worry about the factors. We need two numbers that multiply together to be 2, but add together to be 3. That would be 2 and 1. So when factoring, you always have to think of the signs in b and c. That's going to determine the signs in your factors. In other words, the signs of p and q. So let's take a look at this one. When b is negative and c is positive, okay, we need to find two numbers that multiply together to be positive 8, but they have to add together to be negative 6. Well, they have to multiply together to be positive 8. They either have to be both negative or both positive. But if they're both positive, they can't add up to be a negative number. So they both have to be negative by default. If you take a look at the factors of 8, 8 and 1 do not add up together to be 6, but 4 and 2 do. So in this case, we'd write 4 and 2. The order of these brackets do not matter in this case. When you do not have a coefficient in front of your squared term, the order is irrelevant. So you can put them in either order, either the x minus 4 first or the n minus 2. When B is positive and C is negative, you're going to have one positive term and one negative term. Because in order to get a negative product, one number has to be positive and one has to be negative. So in this case, we've got a negative term here and a positive term here. Now here order is important because you're going to add them together and they have to be a positive 2. Okay, so if you think of the factors of 15, 5 and 3 are separated by 2. But in order for it to be a positive 2, the 5 has to be positive and the 3 has to be negative. Okay? Then when you FOIL that out, you'll get a positive 2y and a negative 15. A little complication of this is if your terms are not on the same side. If they aren't, you have to move them all to the same side before you factor. Never ever factor unless your terms are on the same side of the equation. So in this case, we have the 18 on the wrong side. I would bring the 18 over with the x squared and the 3x. It makes it really easy to factor if the coefficient in front of the x squared is positive, not negative. Don't fool around with negatives in front of x squareds unless you can help it. So in this case, I made it x squared plus 3x minus 18. Again, it's like the example above in that the last term is negative and the middle term is positive. So we know one of our factors will be negative and one will be positive. The bigger one, though, has to be positive because when added together, they have to be a positive 3. Okay? So here we're going to take the x plus 6 and multiply it by x minus 3. Those are the two factors that add together to be positive 3. To solve these equations that you factored, you have to set each factor equal to 0. We did this when we worked with greatest common factors in the previous section. The answers that you get when you set them equal to 0 could be called solutions, they could be called roots, or they could be called, for the first time in this section, the zero of the function. All those terms are interchangeable. Calculating area works really well in this section because area is the multiplication of two terms, the length times the width. So if you have variables in both of those, you're going to end up with a squared term, and then you'll have to factor to solve. In this example, you know the required area is 33 square inches. For example, you have 33 inches of material or 33 inches of plywood. The width is W, and the length of the piece of wood, the material, is W plus 8. If you know those things, you can write the following equation. 33, the area, equals the length times the width. So we have the quantity W plus 8 times W. This is simplified to 33 equals W squared plus 8W. When we bring all the terms to the same side, it becomes W squared plus 8W minus 33. The only way you can solve this is to factor it. Now you need two terms that multiply together to be negative 33. So one's going to be positive and one's going to be negative. But when you add them, they're positive 8. So you know the larger one has to be positive. In this case, it's W plus 11 times W minus 3. But we're not finished because we need to solve it. To solve it, you set each one equal to 0. Okay, remember when we did that in the greatest common factor section. Okay, so in the first case, we're going to get W is negative 11, but in the second one, we're going to get W is 3. Because this is a word problem, you have to have an answer that's logical. Your width cannot be negative 11. That means it wouldn't exist. Your width must be 3. So W equals 3 is the width. The other option is negative and is not possible. The last tricky thing in this section is factoring a trinomial with two variables. Okay? So instead of having Q and P, you're going to be working with Py and Qy if y is, in fact, your second variable. Because you need to get this y squared term at the end. That's how we end up with the y in the parentheses here. Okay? But we still have to figure out what the coefficient is going to be. We need two numbers that multiply together to be 14 and add together to be 9. That's pretty simple. It's 7 and 2. And since both are positive, we just doesn't matter which one goes where. One is 7 and one is 2. When you FOIL this, you're going to find it comes right back to the first equation. Okay? In order to get that squared term at the end, you have to have another variable. So it's a little more complicated than what you were doing earlier in the section, but not so much that I think you're going to have difficulty with it.